Okay, let me record this. So we are going to learn analytical hierarchy process. This is the method where we can deal with multiple criterias, and multiple criterias are for making any decision. Suppose very simple question. You have you want to buy a car. You want to look for reliability, you want to look for aesthetics, you want to look for uh, price part, mileage part, but one car is giving good price but not reliability. One car is giving good reliability but not good look. One car is giving you know both of them, but third factor is not there. So in all this, how you can choose which is the best option in your for buying a car. So these are the multiple criteria, like look, reliability, mileage, comfort, different luxury. So these are for multiple criteria. Based on that, how you can make. For example, you are going to select a CEO of your organization or CIO of your organization. How you have different criteria for selection: education, experience, past technology knowledge, leadership skills. Different, based on that you have four candidates. They are very close to each other. Someone is very good in education, someone is very good in leadership skills. Everything counts. So how you can select, and such multiple criterias related problems, how we can solve. That is what is analytical hierarchy process. There is an advanced form of this which is called analytical network process, and there are other methods, but we are just going to deal with basic method which is called AHP. It was developed by Sati and 1977-98 to model subjective decision making process in a hierarchical system. It provides measure of judgment of consistency, and it is based on decision criteria using two pair comparison. So basically pairwise comparison is most important criteria of this method, and it starts with pairwise comparison. It is popular and widely used method for multi-criteria decision making, allows the use of qualitative and quantitative criteria for evaluation. So basically, this method has qualitative as well as quantitative approach or criteria in evaluations. So all problems are considered hierarchical in structure in the AHP. So some of the example can refer to corporate planning, portfolio selection, benefit cost analysis. Wide range of application exists: choosing a CEO or CIO, hiring a CIO or CEO, promotions of staff, buying a house, buying a car, deciding upon a plan to visit a vacation, deciding upon an MBA program after graduation. So, many situations where you can do this. For example, in India, one of my friend has selected this approach to do his marriage. So he's selected a life partner based on this criteria. What does AHP do? It develop a hierarchy of decision criteria and define the alternative course of action. Basically composed of two steps: relative weights of decision criteria and relative ranking of alternatives. So these are the two things we are. It has qualitative. So let me go directly into the example so that you can look into this. So very simple example, we would like to buy a car. selecting a car or buying a car, criteria is based on three aspects: style, reliability, and fuel economy. And fourth is cost, which will be done later. So basically three criteria: style, reliability, and fuel economy. Alternative options you have Civic, Saturn, Ford, and Mazda. These are the four cars you have based on style, reliability, fuel economy, which is going to be your first preference, which is going to be your second, third, and fourth. So we are going to do the decision making. Based on this, first step is to develop hierarchy. So this is selecting a car based on style, reliability, fuel economy. Four options: Civic, Saturn, Escort, and Mazda. So these are the four options. So this is the hierarchy that we have developed. Now, second step in this is to do pairwise comparison. How do we do pairwise comparison? So basically, this is the method that you can apply to do. So I'm just giving a very simple example here in real way. Let's say population of Seattle and Spokane and Seattle. What is the population of Seattle? Approximately 1 million. What is the population of Spokane? Almost 2.5. 250,000. So 0.25 million or 250,000. Either way we can write. So we can say, if I say Spokane is 1/4 of Seattle, can we say? Or in other word, we can compare Seattle to Spokane, and we can say Seattle is 4 times bigger to Spokane. Exactly same thing is going to be applied here. Or another example you can take. New York is 10 times bigger than Seattle, and Seattle is 1/10 of New York City. So same criteria we are going to do. So what you are going to do, you are going to make a scale. How we are going to make a scale? For example, 1 is right here. 1 is right here, so I just put 1. And then 1 to 9 point scale is here. 2, 3, 4, 5, 6, I mean up to 9 you can say. And this here also you can go to 1 to 9 point scale. So 1, 2, 3, 4, and up to 9. Let's say this is a Seattle, and this is Spokane. Okay, so if I compare Seattle or Spokane, Seattle is 4 times bigger than Spokane. So what would be the situation? So, this is 1. 1 is right here. 1 means both are equal. So if Seattle is 10 million and Spokane is 10 million or 1 million, it would be 1. And reciprocal of 1 is, so this is 4 times bigger than Spokane. So this is the way you can get the primary information, or you can get this pairwise. Here intensity ranking the scale of criteria. So basically 1, 3, 4, 5, 6. So you can do this. Now look into this. So the first matrix has been developed based on the pairwise comparison. We read from this way. This is the way of reading. So the style, reliability, fuel economy, and reliability. So you can say style to style is same. Reliability to reliability and fuel economy to fuel economy is exactly same. Now look, style to reliability is half. Means people prefer style to reliability half. Means style is half preferred than reliability. That means reliability is 2 times importance than. So if I see here, I put the scale here, and this is 1. I put here style. I put here reliability. So 2, 3, and all the way to 9. So 2, 3, all the way to 9 here. So here reliability and style. So reliability is 2 times preferred than, so this 2. So reliability is 2 times preferred than style. Therefore, what is the value of style preferred over reliability? Half of this. Means this is reciprocal of each other. You can see this. This is most important, and we make mistakes when we are making this initial pairwise matrix. So normally what happens here, this is half, this is 2. Now look into the style is 3 times preferred than fuel economy. So fuel economy is 1/3 preferred over style. So these are reciprocal, you can clearly see. Now similarly, the fourth option, this is third, reliability and fuel economy. Reliability is 4 times preferred over fuel economy, and this is preferred 1/4. So if this is clear, this pairwise matrix is clear, we can move further. And we don't need now we don't need Excel. Minitab. We are going to work with only Excel. So I'm just going to open my Excel to do calculations. If this is clear, so style, reliability, fuel. So I'm just going to style, reliability, fuel. So here I'm also going to style, and fuel economy. So let me make this. So this is the matrix that just created, and okay, now we are going to put 1, 1, 1. So this is 1 point, which is 0.5. This is 2. 3, 4, 1. This is 1/4 means 2.25. And this is, what would be the value of this? Fuel economy 1/3 means 0.333. So this is our matrix. You can see the consistency of the matrix. If this is clear, the next step is we are going to normalize the matrix. How do we do the normalization? We are going to take the sum of this, and we are going to divide with the sum of the column. So the sum of this 1, 2, and 0.33, which is 3.33. then 1 divided by 0.3, 1 divided by 3.33, 2 divided by 3.33, and we are going to get normalized matrix. Now, so I'm just going to do sum. So this is the all three. Now I have to do what I have to do. I'm going, this has to be divided by this has to be, so I'm going to make a new matrix here that you can clearly see. So equal sign 1 divided by this. You know, you can do product, you know, there are options under Excel that you can do, but I'm going to do step by step so you can understand. So this is the similarly divided by 1.75 equal to 1 divided by 1.75 and 0.25 divided by 1.75. Similarly, I'm going to do this 3 divided by 8, 4 divided by 8, and 1 divided by 8. So this is our normalized matrix. How we can check the normalized? The sum of each column should be 1. So we are going to check sum. This is 1, which is normalized. This is 1, which is normalized. This is 1 that is normalized. So we got the normalized matrix. Now here we are going to do the second thing, which is row average. We are going to take the row average. So let's do the row average. So equal average sign, average operation, and I'm going to do this. And I'm going to do exactly for all. And that is also coming 1. So we have done this. Now this was style, reliability, and fuel economy. So if you can see, this is the weight of style, this is the weight of reliability, this is the weight of fuel economy. So here you can see, I mean, they have just rounded the things. Style is given 30%, reliability is 60%, fuel economy is 10%. So selecting a new car has been divided into weights. Style 30%, reliability 60%, fuel economy 10%. Now next step is to calculate the consistency ratio. What is consistency ratio? To measure how consistent the judgment have been relative to large sample of purely random judgment. We would, you know, so this checks the consistency of your judgment. That means pairwise. So if consistency ratio is greater than 0.1, the judgment are untrustworthy. That means if consistency ratio is more than 10%, the judgments are untrustworthy because they are too close to comfort to a randomness, and excessive is valueless or must be repeated. So this is, you know, you have to, you know, remember that it should not be more than 0.1. So here, how to do the calculation? We are going to do that thing. So again, we take original matrix, which is this that we have started. These are the weights, and we are going to multiply this with the weight. So let's look into this. So this is the original thing. I'm just copying this and I'm just putting here. And now I have these weights, which I'm going to make it 0.3, 0.6, and 0.1. For easiness, I'm just, I'm just following the 3, 6, and okay. So how do we do this? So 0.3 has to be multiplied with this, 0.3 has to multiply it with this, 0.3 has to multiply it with this. So this multiplied with this. This multiplied with this. This multiplied with this. Similarly, we are going to do this 0.6 multiplied with point. Oh, I am doing something wrong, probably. So this is correct. This is just, so this is F25, which is correct, multiplied with F, which is correct. And this is F26 with, this is correct. So, and then this multiplied with, there's this. Then this multiplied with this. Then this multiplied with 0.25. Similarly, we do for this point, this multiply. And then so we got this. Now we are going to do sum of the row. So equal to sum . So if you see 0.9, 1.6 and point, so they have just again rounded up to this value. So this is multiplication of A into X, which is AX, and now equal to lambda max divide into 0.3, 0.6, 0.1, which is, again, what we are going to do again now, we are going to take, divide 0.9 with 0.30, which is the weight of style. 1.6 divided by 0.60 and 0.35 divided by this. So we are going to take the average of everything. So this is what we have now, and we now just do 0.3 is this style, 0.6 is this, and 0.1 is this. So what we are going to do, we are going to take this divided by this, this divided by this, and this divided by this. So what we get here, which is the average should be of all 3 point something. So this is the average 3.5 or 3.6, everywhere they are just rounding up. So this is the value that is important for us. So lambda max value we got 3.06. Now consistency index equal to lambda max minus n divided by n minus 1. So how many n means number of criterias? We have 3 here. style, reliability, and mileage. Yes. So we have lambda max minus 3 divided by 3 minus 1. So we are just going to check this. So equal to lambda max is this minus n, which is and then divided by 3 minus 1. So I'm just going to put 2, you know. So, or you can say 3 minus 1. How much we are getting here? The value is close to less than 2%, less than 3%. So, and you know the consistency. So CI equal to, sorry. So this is consistency index, CI equal to 0.03. So consistency index is 0.03 in 0.03. Now we are going to check consistency ratio. So consistency ratio is based on this, you know, Sate scale. So for one consistency index equal and divided by, so consistency index divided by this ratio, consistency ratio. So basically for a, you know, this is called corresponding index of the consistency of random judgment. So for example, if there are 1 which is 0, for 2 0, for 3 criteria 0.58, for 4 criteria 0.90, for 5, and so on and so forth. So we have 3 criteria, so that means 0.58. Okay, so this you can see 0.03 divided by 0.8, which is coming 0.05. So here I'm just going to go for consistency ratio equal to 0.03 divided by 0.05, 0.58, 0.58. So here we are getting 0.08. 0.03 divided by 0.58. So here it is coming 0.05, doesn't matter. We are getting our XL, which is again less than 0.1. So, or you can put this. So this is less than 0.1%. That means what we can say, our evaluations are consistent. So consistency ratio is very important in order to check the consistency of your judgment. And that's how we do it. First we do the lambda, then we find consistency index. That consistency index has to be divided by this, you know, this scale given by Sate, and then you can get the consistency ratio. If your consistency ratio is 10% or less, you can say your judgment is good. An inconsistency of 10% of less implies the judgment is small as compared to actual values of eigenvector entries. A consistency ratio as high as say 90% would mean that pairwise judgment are just about random, and in this case comparison should be repeated. So basically this is what we have to do, you know, which is we can tolerate. Now so this is now, so our first, this is valid, this scale, this first criteria has been consistent, this is valid. Now we are going to the next part. Now we are going to check the style and ranking alternatives. Again, we are going to do the pairwise comparison. Civic to Civic is 1. Saturn to Saturn is 1. Escort to Escort 1. Mazda to Mazda 1. Now Civic is Civic is 1/4 preferred over Saturn. Civic is 4 times preferred over Escort. Again, you can do the same pairwise comparison. And Mazda is preferred, Civic is preferred 1/6 of Mazda. Saturn, so this is 1/4, therefore here the 4th. This is Saturn and Escort. Saturn is 4 times preferred that as compared to Escort, and 1/4 as compared to. So basically, based on style, based on reliability, you have to make the these pairwise matrix. And again, the same method that we do, here to get up to this value. These are the eigenvector. So first you just do this, normalize them, means you are going to normalize. So this is normalized matrix, and then you take the average of this. So average of normalized matrix is called eigenvector or priority vectors. So here you can get these values. So Civic is 13%, Saturn is 24%, Escort is 0.07, Mazda is 0.56. In style, reliability, Civic is 0.38, Saturn is 0.29. Similarly, we go for third option. Third option, since it is not pairwise comparison, we can directly do, because we have mileage per gallon, we have the real values, which is based on the claim by the cars. Total is 113 miles, then 34 divided by 113, 27 divided by 113, 24 divided by 113, 28, and we get the normalized value like this. So 0.34. Now we have our consistency final hierarchy to make the decision. Okay, Civic, in terms of style, Civic, all 4 cars eigenvector. In terms of reliability, all 4 cars eigenvector. In terms of fuel economy, all 4 cars. Now, how do we do? So I'm just going to do for Civic. So Civic value, reliability is 0.3 multiplied with 0.13 plus reliability is 0.6 multiplied with 0.38 plus fuel economy is 10%, 0.10 into 0.30. Similarly, we do for Saturn, Escort, and Mazda. So if we do all these things, we get the overall our decision. So this is, again, they have done this multiplication with this way, priority matrix, criteria weight. So what we are getting here, Civic is overall 30%. Saturn is overall 27%. Escort is 8%, and Miata or Mazda is 35%. Now, based on all these three criteria and 4 alternatives, what is our decision? If I would like to buy, I will go first. This is my first car. I will go for Mazda. Second, I will go for Civic. Third, I go for this, and 4 I go. So you can even rank these criteria in order to see which is the highest, most valuable car based on style, reliability, fuel economy. Second, third, and fourth. So this is, now you can normalize, for example, include, suppose once you have done this three criteria and now you are going to do include fourth criteria, then what you have to do, you can't directly include like this. You have to start, because it is 4x4 matrix, because after style, reliability, fuel economy, cost is another. So cost will be compared with pairwise with style, cost will be compared with pairwise with reliability, cost will be compared with mileage, and then it will be, so you can't add this. So this is the AHP method. If you understand it, if you have real data, you can do that. Now here is some of the application. A family of average income wanted to buy a house and identified 8 criteria that were important for them to select a best house: size, transportation, neighborhood, age, yard, modern facilities, general condition, and financing. Based on that, they have selected 3 or 4 or 5 houses. Okay. Based on that, this is the consistency ratio index, which is 0.8% close to. So first, what they have done, based on size, transportation, and all, this is the pairwise matrix, and this consistency ratio is less than 10%. Then based on size, you are going to compare all 3 house. Based on transportation, you are going to compare all house. Based on neighborhood, all house. Age, yard, modern, and then finance. So, and then overall, A is giving 34% or 35%, B is giving 36%, and C is giving 28.5%. So I will go and buy house number B based on size, transportation, neighborhood, age, yard, modern, things, condition, and finance. Based on all these factors, I will prefer first option is this. How useful is this method? So for example, this is the, pairwise comparison of which drink is consumed more in USA. And this is an example estimation using judgment. So basically based on this AHP method, coffee, wine, tea, beer, sodas, milk, and water, they were compared with each other pairwisely. And based on that, this is, what is the actual, based on judgmental, this comparison based on this, these are the values of pairwise matrix, or, or you can say the weight of each thing. Coffee is 17%, wine is approximately 2%, tea is approximately 4.2%, beer is almost 11.6%, sodas. So based on AHP, these are the values that we determine. With consistency ratio is around 2%. Now actually based on statistical source, based on US government statistical source, what is actual consumption in United States? The coffee is 18%, and we are coming very close to, based on judgment. Wine is 2%, here wine is 1%. Tea is 4.2%, here tea is 4%. Beer is 11.6%, beer is 12%. Sodas is 19%, 18%, milk is 13%, here 14%. Water is 32% and 32.7. So all the results are compared with real statistical data versus this AHP method, and they are coming very close to each other, almost same. So Now estimate which food has more protein. So A, steak, potatoes, apple, soybean, whole wheat, tasty cake, and this is a pairwise. You have to make, this reciprocal in matrix. This is a matrix. Now you have to fill the reciprocal values, and then you need to determine. So here this is derived and this is actual. So you can see, and which is consistency ratio is less than 3%. So you can see how close this method is applicable. Now, who will be your president or who will be your CEO of your company based on this? Based on this matrix, can you give the judgment? Mr. Clinton is going to be clear, and Margaret Thatcher is, I think, third one or second one. I think second one. And George Bush would be the third one. So this is about AHP method, and you have very simple method that can be applied for selecting many things. And even prioritizing, which is first alternative, second, third, fourth. Suppose you want to give a promotion to employee, you are not confirmed, you can make a ranking, he will be promoted first, he will be promoted second, and so forth. So if you have any question, you are most welcome. If you don't have any question, I would like to say have a good night. Any question? Thank you so much. Have a good night, and bye-bye.